All right, so first example I am going to do is 1 plus root 3i into polar form. You'll see a lot of square roots in the questions that might seem tricky, but it actually will make them easier because the angles will work out to be whole number angles rather than the 53.13 degrees you might have saw in the 3 plus 4i example I did previously. The 1 plus root 3i, with all of these, just draw a quick argon diagram out. Where would that be? 1 plus root 3i. It doesn't really matter if it's to scale or not. So I've got my right angle. What do I need? I need this angle and I need the modulus. Okay, so the modulus here is going to be the square root of a squared plus b squared. So it's going to be 1 squared plus root 3 squared. So that is the square root of 1 plus 1 plus 3. So root 4, which is equal to 2. So my modulus is 2 here. The other thing I need is the angle. So right angle triangle. This side is 1 unit. This side is root 3 units. This one we know now is 2, but I would tend to use the 1 and root 3 because I'm given those in the question. They're definitely correct. You might have made a mistake with that one. So I would use the 1 and the root 3. So this angle here, if I'm using 1 and root 3, I'm using opposite and adjacent. So the tan of theta is equal to root 3 over 1. So theta is the tan inverse of just root 3. So second function, tan root 3 is equal to 60 degrees. That's what I mean about the whole number angles. So theta is equal to 60 degrees. So polar form, remember, z is equal to or times cis theta. So it's 2 times cis 60. And that's it in polar form. You can write the cis out in full. You can write 2 cos 60 plus I sine 60, but 2 cis 60 is fine. All right. So moving on now to another example. So I've got minus 3 plus 3i in the form or cos theta plus I sine theta. So that's in polar form as well. This is the way they ask them in the book. They don't really introduce cis quite yet. So they're saying cos theta plus I sine theta rather than cis theta. It means the same thing. So again, just draw your quick argon diagram out. Minus 3 plus 3. So minus 3 will be here. 3 would be here. So that's minus 3 plus 3i. So I'm looking for that modulus, and it's this angle that I'm looking for, okay? Because I'm always doing the angle from this line here. So it's this many degrees and then whatever the modulus is out. So let's get the modulus first anyway. So that is the square root of a squared plus b squared. So the square root of minus 3 squared plus 3 squared. So that's the square root of 9 plus 9. So root 18. And I would just leave that as a square root. I wouldn't work it out. You can maybe plug it in and get it in third form, maybe to just 3 root 2. All right, but no need to change it to decimal and round off. To get the angle then, all right, what I'm going to look at is this right angle triangle here. I'm going to figure out this angle, and then if I take it away from 180, I'll get that angle there that I'm actually looking for. So So this is my right angle. This is 3 units. I know it's -3, but it's distance, so I'll just use 3. They use minus in some of the examples you see. I tend to just look at it as a right angle triangle, ignore the signs, deal with that when I'm doing the angle later. This side here will also be 3. This is what I'm looking for. All right, so it is opposite 3, adjacent 3. So the tan of x is 3 over 3. So x is the tan inverse of 1. What is the tan inverse of 1? It's 45 degrees. So if this angle here is 45, then the theta I'm looking for is 180 minus 45, which is 135 degrees. So in polar form, which is or cis theta, I've got 3 root 2 times the cis of 135. And again, you can write that out in full, write it as or cos 135 plus I sine 135. It means the same thing. If they ask for it in this form and you write cis, it is the same thing. It's correct.